Okay, like it in writing equations of lines, where there were multiple forms that we could write them in, slope-intercept form, standard form, and also point slope. There are multiple forms to write equations of quadratic sum that result in parabolas. So this is the video on vertex form. You've done a little investigation about vertex form now, but we're going to kind of finalize some of those things. So just reminders about standard form of parabola. What information can we get from the standard form? We can get the vertex. So remember the x-coordinate here is negative b over 2a as far as those values in standard form when it's written ax squared plus bx plus c. And just a note about the notation here. So the x-coordinates are negative b over 2a, and then this is the y-coordinate. If you remember this notation, f of, this is telling you to plug in. So how do we find the y value? This is telling you to plug in the value you got for negative b over 2a into the equation for x to get the value out. So f of, that's function notation telling you to plug into x. Okay, axis to symmetry, we can get, again, it goes through the vertex, it shares an x-coordinate with the vertex, it's x equals because it's that vertical line that we should use us to help us graph. And other information, the y-intercept can easily be seen from the standard form, and then also the parabola opening up when you have that positive a value and opening down when you have a negative a value. So information that can be fairly easily gotten from standard form of a parabola. Now when we talk about vertex form of a parabola, this format that you saw in the investigation looks a little bit odd, but can actually give you some really easy information, and that's kind of the idea of using it. So the vertex in this form, this a x minus h squared plus k, we're using different letters, different variables, because they represent different things. The h and the k here represent the x and the y coordinate of your vertex. Hopefully you saw that matchup in the investigation, whether you were looking at vertex form or standard form. You're talking about the same parabola, but different ways to get the information you need. So if this is the vertex, those are the x and y coordinates, think of the axis of symmetry goes through that x value of the vertex. So again, those two values are easily obtained. Other information, as far as what vertex form tells you, it doesn't give you the other information like the y-intercept very easily, but it does again tell you about that opening up and opening down of the parabola. That a value continues to have that kind of that same function. So how are we going to use vertex form? Well, we're going to graph it, and we're going to be writing equations in vertex. And the idea of graphing an equation in vertex form, you can use similar ideas as we've done with graphing before. I mean, idea of 5 points, but you might have to do a little bit less work for some of those points and a little more work for others. I would suggest, so this is the way I suggest to easily graph vertex form, and the easiest way to do it is to start with the vertex. So if you remember, the vertex is, and here's my general form, my vertex is h comma k. So when you're identifying those values, that h and that k value, you have to look at what that format of vertex form says. It says x minus h here. What would I have to plug in? So you need to think about the h value here is what I would plug in to make this x minus 3. What would the h value had to have been to turn that into x minus 3? The h value would have had to have been positive 3 in order to maintain that minus. So this would be 3 comma the k value, so it's plus k on the end. How do I make minus 5? Well, my k value must be negative 5. So my vertex is at 3 comma negative 5. What other information can I get? Well, the a value is positive, so I know I'm going to have an upward facing parabola. And my axis of symmetry is at x equals 3. Okay, so how am I going to get my 2 other points? Well, or not 2 other points, my 4 other points. From here, it's kind of, you have to do a little bit more work. So it's kind of up to you how you want to do this. If you want to get specific points, if you want to get the y-intercept, for instance, you can certainly do that, but it's not going to be, it's going to involve some calculation. So what I suggest instead, at this point, just to get our parabola kind of finished, is to just use making a table, and not just pick random points here, but so we're picking x values and we'll plug them in to get the y values. Pick x values that are close by to where your vertex is. So I'm going to pick, for instance, I'm going to pick x equals 2. And when I plug that in, we have 2 times 2 minus 3 squared minus 5. That's 2 times negative 1 squared minus 5. So parentheses first, then exponents, 2 times 1 minus 5, then multiply. So my point is 2 comma negative 3. Now, having that axis of symmetry here, really I don't need to find 4 more points individually. I need to find a point, and then I can use the axis of symmetry to reflect it. So from getting the point 2 comma negative 3, I also got the point 5, oops, sorry, not 5, 4 comma negative 3. Okay, so I'm going to plug in another x value. Let's plug in 1. 2 times 1 minus 3 squared minus 5 is 2 times negative 2 squared minus 5. 2 times 4 minus 5, that's 8. Minus 5 is 3. So I have the point 1 comma 3. And from that, I can reflect that point, and that gives me the point 5 comma 3. So from finding 2 more points, I actually gained 4 points because I reflected them. And now I have a pretty decent looking parabola. If I had found the y-intercept, if I had found the zeros, I can do that. It's just I chose not to. You can always plug in values to get the shape of your parabola. It's just always good to start from the vertex so you kind of have that center of the parabola going for you. All right, your turn to graph an equation. So pause the video and try this problem. So your vertex, h comma k, thinking about again, what would you have to plug in here? If I was going to get positive 1, it would have to be x minus negative 1. So h is negative 1, and this is plus k, so k is positive 4. Negative 1 comma 4. My a value is negative 1, so I'm going to have a sad face parabola. And my axis of symmetry, I'm going to go ahead and write that in. That's x equals negative 1. Okay, so a couple more points. I'm going to plug in x as 0 because that would be an easy one to work with. 0 plus 1 squared plus 4. So that's negative 1 squared plus 4. That's negative 1 plus 4, which is 3. So 0 comma 3. The y-intercept is 0, 3 that we just found. Okay, reflect that point. So that's negative 2 comma 3. And then I'm going to plug in one more value. I'll plug in x equals 1. Negative 1 plus 1 squared plus 4. Negative, and I have to square these before I can stick the negative on. So that's negative 4 plus 4. So that's 0. So I have, oops, I went the wrong way, but I have 1 comma 0, and then reflecting it, I have negative 3 comma 0. So I happen to, on this one, based on the points I selected, actually find the y-intercept and the zeros by chance on this particular problem. So graphing vertex form is about kind of centering yourself on the vertex and utilizing what you know about axis of symmetry. Okay, so the last thing we're going to do with vertex form here is talk about changing forms of equations. So we don't just want to have standard form and be stuck with standard form, and have vertex form and be stuck with vertex form, because there may be times where we want to use one or the other. So if I have an equation in vertex form, it's actually pretty simple, and you've seen this a little bit already in the investigation. Changing into standard form just involves multiplying out, so squared x minus 3 squared, multiplying that out as x minus 3 times x minus 3, going ahead and FOILing it on out, combining your like terms, just doing some multiplication, a bunch of multiplication, and then simplifying any of your like terms. So vertex form into standard form is just about multiplying out your values. Going from standard form into vertex form, though, is a little bit trickier. If you kind of look at going backwards here, it's not exactly going to be super straightforward. But hopefully, looking at this vertex form and this x minus 3 squared portion reminds you of something that we've done recently, and that is that idea of completing the square. So to change forms from from standard form into vertex form involves completing the square. And I would suggest writing these steps down, and if you don't normally write these problems out, because getting more practice is definitely a good thing. Okay, so to complete the square, what we need to do is we need to take this and we need to complete the square with it. 2x squared minus 12x plus 23. Okay, to complete the square though, and we didn't talk a ton about this, but to complete the square, what you have to have, the first thing you have to have is you want to have, only an x squared value. When we complete the square off that, we don't want to complete the square off of 2x squared, because if you think about when we multiply out like x plus 3 squared, that's x plus 3 times x plus 3, to get that first value, that a value, and we FOIL this out, we're going to come up with just x squared. We're not going to be able to multiply a parentheses times itself, and not with an easy number, to get to x squared, or most numbers that start out here. So what we want to do first is kind of set ourselves up for completing the square. So we're going to take this portion of the equation, this first portion, 2x squared minus 12x, and we're going to kind of separate off this 23. We don't want to, again, we don't want to factor completing the square with just this being 2x squared. So what we're going to do here is we're going to factor out the 2. We're going to have x squared minus 6x, and I really don't care to factor. This 23 is kind of that balancing factor in the end. We don't really care to have to factor 2 out of that. So I'm just going to, again, leave this 23 off to the side. And now I want to figure out, okay, what am I going to use to complete the square here? So divide negative 6 by 2, and then square that value. So I'm going to complete the square by adding 9. Okay, so now I need to balance that choice out. This is y equals, continuing that down there. How am I going to balance this out? Well, okay, think about it this way. I added 9. I don't really want to put anything on the other side of the equal sign here. So I didn't just add 9 here. What did I really do? What's happening to this 9? This 9 is being multiplied by this 2. So it's really like I added 18 here to this side of the equation. How can I balance it out? Well, I can add 18 to the left side of the equation, or I can balance it out by subtracting 18 from the right side. So adding 18 to the right side and subtracting 18 to the right side balances each other out. So if I take this now and if I were to factor this, and I could go through the longer process of factoring, but from experience I know this perfect square factors as x minus 3 times x minus 3. 23 minus 18 is 5. So completing the square is kind of the secret to going from standard form into vertex form. I know that might have been a little quick, so if you want to go back and look at that process again, but here's a problem for you to try. And because we're out of time, I will share the answer with you when you have finished watching the video tomorrow.